Hi everybody, welcome to the 5.3 dilation notes. Again, I will be going through the notes today. I will also provide a copy of these notes, blank notes for you guys if you need to look at them at a later date. Feel free to pause the video at any time as you're going through it. There are about, 11 slides to go through today. You'll see a lot of similarity between what we do today and our 5.1 similar polygon. Okay. Now, some of the terminology is similar, but the application is a little bit different. So first of all, definition. A dilation is a transformation that produces an image that is the same shape as the original, but it is a different size. A dilation stretches or shrinks the original figure. The description of a dilation includes the scale factor or ratio and the center of dilation. Okay, so dilations, this is considered a transformation. Okay, but it's not a rigid transformation. Rigid transformations, the images stay locked in their size. Okay, in a dilation, it's going to get bigger or smaller. Okay, it's definition of it. Okay, the scale factor, we usually use the variable k for our scale factor. If the scale factor is between 0 and 1, the dilation is a reduction. Okay. If the scale factor k is greater than 1, then the dilation is an enlargement. Okay? This is an example in our diagram here of an enlargement. ABC is the pink triangle in the middle, and it looks like it has a scale factor of 2. It looks like all these vertice coordinates are doubling. Okay? Looks like A goes from -2, -2 to -4, -4. So this would have a scale factor of 2. Everything is doubling. Okay? A dilation of scale factor k, for whose center of dilation is the origin, may be written like so. Okay? Now, a lot of times, and we've been using our rules, okay? And here's how we would write down the rule for something like this. We would say x comma y maps to k times x and k times y. All right, same idea as what we have here. We could make this little arrow and make it a maps to. All right. Again, scale factor greater than 1, it's a stretch. Scale factor between 0 and 1, it's going to shrink. It's going to get smaller. Let's look at a couple examples. We're going to dilate the figure on the right according to the following rule. All right. So if we have our coordinate here for P is at 1, 1, all right, P prime would be at 2 times 1 and 2 times 1, so that's going to be at 2, 2. All right, so we would go to 2, 2. There is P prime. Now Q is at 1, 3. It's going to map to Q prime. Again, we're doubling these, so that's going to be at 2, 6. 2, 6. Q prime. And the last point, R, is at 3, 1. That's going to map to R prime, which is 6, 2. 6, 2. All right? R prime. Now, if we connect our dots, there is our new triangle, which is an enlargement. Okay, this is an enlargement of our original one. It's about twice as big. That makes sense because it has a scale factor of 2. All right. Now, these are all being, unless it states otherwise, you're dilating everything from the origin. Okay, so everything is come back. So everything in this case, all right, is extending from the origin out. All right, and what's kind of neat is you can always draw a line from the origin. It should go through both your points, the original point and the dilated point, okay, because it's all extending from the origin. All right, there's one example. Here's a reduction example. Dilate the following figure according to the following rules. All right, now Sometimes you are going to get some decimals or some fractions. We try not to do that very often, but sometimes it does happen. So let's look at point P here is at -7, -6. So P is at -7, -6. All right. It's going to map to P prime. All right. So 2/3 of -7. I'm going to use a calculator. Okay. So 2/3 times -7 is -4.6. It's about 4.7. -4.7. All right. And 2/3 of -6, that is going to be -4. All right. So -4.7. So -4.7, -4, it's going to be about right here. Right? Is it exact? No, it is not exact, but that's about where it's going to be. All right, let's do our other 4 points. R is at -4, -4. All right, and we go to R prime. So I'm going to do I do 2/3 times -4. I get -2.7. It's about -2.7. All right, and they're both going to be -2.7. So if I go -2.7, CQ, -2.7, -2.7, it's going to be right about here. Okay, so we've done P prime and R prime, which are opposite one another. Let's go ahead and do S. S is at -3, -6, -3, -6. All right, 2/3 of -3 is going to be -2, and that'll be -4. So -2, -4. There is S prime. So we got S prime, R prime, P prime. So we have Q left to go. Q is at -6, -4. Maps to Q prime. That's going to be -4. Let's see, -2.7. So -4, -1, 2.7. All right, Q prime. Let's connect our dots here with our line. So we go from here to here, to there, to there, to there. All right, there is our reduction. Okay, it is getting smaller. And again, remember, if we were to draw lines, we should be able to draw lines straight through all these points, and they would work their way through the corresponding points on the original as well. Okay, and that's because we're dilating about the origin. So not only is it getting smaller, but it's getting smaller towards the origin. All right. You know what? I forgot my picture on this one. Let's see if we can draw a picture real quick. We're going to be doing a scale factor of 2 and a center at 2, 1. 2, 1 is where the center is going to be. All right. Let's see. Let's just do a square. There we go. Yeah, we'll do a triangle. All right. So let's say we have an image here and it says dilate the figure below using a scale factor of 2 and a center of dilation at 2, 1. So this is different. This is not, we don't have our center of dilation at the origin now. It's at a different place. Here's what I recommend that you do, okay? Go ahead and take your drawing tools. Now in this case, I'm going to draw my lines here. I'm going to change my color. I'm going to make it a lighter color. I'm going to go with yellow. What I'm going to do is I'm going to draw a new set of axes. Okay, I'm going to draw a new pair, and I'm going to draw it like this red point at 2, 1, which is the center of dilation. I'm going to make that like my new origin. Okay? Now, what I'm going to do, now that I've got my new origin here, I'm going to go ahead and dilate this green triangle about my new origin. Well, there's new coordinates here as well. Okay? So, let's say we name these A, B, and C. Okay? So, we got point A, B, and C. Well, we're going to dilate with a scale factor of 2. Okay? So, if point A, let's see, with my new axis, point A is at 0, 1, 2, 3. So 0, 3. And I'm going to map it with a scale factor of 2 to A prime. So I'm going to double each of these points. So 0 times 2 is 0. 3 times 2 is 6. So A prime is going to be at 0, 6. I'm still using my yellow axis here, though. 1, 2, 3, 4, 5, 6. There's A prime. All right. Now I'm going to do B. B is at 1, 2, 1, 2, 1. B is going to map to B prime. I'm doubling these, so 2 times 2 is 4, 1 times 2 is 2. So we're going to go to 1, 2, 3, 4, 1, 2. There's B prime. Now C, all right, C is at 2, 2. So I double them. C prime is going to move to 4, 4, 4. Let's see. 4, 2. I feel like I did something wrong. Oh, I'm using the wrong axis. Sorry. C is at 0, 1. Let's do these again. C is at 0, 1. I was using the wrong ones. You have to be careful when you're doing this. So I'm going to double. That becomes 0, 2 because I'm doubling them. So 0, 2. So right here would be C prime. So if I draw my new triangle, I'm going to do line, but I'm going to change my color again. We're going to do, let's do a purple one. Connect my points here to there. Okay, now this purple one is a dilation of the figure by scale factor of 2, so it's about twice as big. But in this case, I'm dilating from this point, okay, not from the origin. And it makes sense because remember, I can usually draw from where I'm dilating from, and it should cross the 2 points. Well, it would do it this way as well, okay? But again, it would all dilate out from this point, from right here, the point 2, 1. So we just kind of treat that point of dilation as our center of dilation, okay? And again, use a drawing tool that you have. Use the drawing tool you have within Desmos or within Edge Elastic. You can make that new axis, okay? And within that new axis, you can then identify the coordinates that you're going to dilate from. All right. Okay, shifting a little bit. Now we've got some things that are not in a coordinate plane, all right? But we still have scale factors, all right? We still have some scale factors. And these scale factors are a little bit different, okay? We got to think about what are we going to multiply things by, okay? Is it a reduction or is it an enlargement? And you got to make sure that your numbers fall between. If it's a reduction, then your number needs to be between 0 and 1. If it's an enlargement, it needs to be a number bigger than 1. So in this case, we're going from ABD to A prime, B prime, D prime, which in the center of dilation is point C. It looks like it's getting smaller. So it looks like right away, I know this is going to be a reduction. All right. But how much of a reduction? Well, we know the distance from C to D prime is 3, and the distance from C to D is 6. Okay. So it looks like it's half the distance. Well, guess what? We can use that as our scale factor. All right. It's basically cutting everything in half, becoming half the size. Half the distance away, half the size of our side lengths. Okay, so our scale factor here would be 1/2. And we basically used, all right, we used the distance away from the center of dilation. Okay, let's look at another example. Reduction or enlargement and our scale factor. Well, it looks like A, B, D, E is the blue, A prime, B prime, D prime, E prime. So we got the primes here. That's the second one. That's the bigger one. So it looks like we have an enlargement. Okay, we have an enlargement. Now we can do the same thing. We can use distance to figure this out, but it's not the same. On the last one, okay, we were given that 6 is the distance. On this problem, we're given that the distance from C to A is 4, and then from A to A prime is 12. But we need to figure out what this total distance is. Okay, so if that's 4 and that's 12, the total distance is going to be 16. And that's important, okay, because you can't just compare 4 to 12. We need the total distance from C to A and then from C to A prime. All right, so we know it's an enlargement, so we know this number needs to be bigger than 1. Well, let's compare the distance to our enlargement to the distance to our original. 16 over 4, well, 4. Okay, 16 divided by 4 is 4. You could write it as 4 or 4 over 1. Okay, but again, that scale factor is bigger than 1. And this picture is about 4 times the size of the enlargement's about 4 times as big as the original. All right, here's another one where our center of dilation is actually on the figure. It's point P. This is our center of dilation. All right, so everything's extending out from here. Or I should say out or in. Let's figure out which one it is. In this case, our regular points are on the outside and our prime points are on the inside. So this is definitely a reduction. So I need a scale factor. I need to figure out what my scale factor is. It's going to be getting smaller. All right. So that means we need to put the 2 goes on the top, 4 goes on the bottom, because that's the only way between we compare these two lengths that we're going to get a reduction scale factor, which is between 0 and 1, reduces to 1/2. There's our scale factor. Okay, 2 more. Here we have another one where our center of dilation is located on the figure, and it looks like it's going to be an enlargement because it goes from the blue to the red, Q to Q prime. So we have an enlargement. All right, so take the prime length over the starting length. This is going to be bigger than 1, and we can write it as a decimal or a fraction. If I leave it as a fraction, this is 3 over 2. All right. If I write it as a decimal, it'd be 1.5. Either one of these would be correct. Again, feel free to pause these if you guys need to and I'm going too fast. All right, here's one where find the scale factor x, find the scale factor x and y. All right, so the first thing we need to do is find our scale factor because we can't solve for x and y unless we do. This is similar to when we had our similar polygons and we knew what the scale factor was and we were able to set up proportions. That's what we're going to do here, but we have to get our scale factor first. So we need to identify 2 sides that have lengths. So it looks like AE and A prime E prime do. All right. Now it looks like this is going to be it's an enlargement. So I'm going to put the bigger on top. So 15 over 9, which that reduces to, I'm going to leave this as a fraction, 5/3. There's my scale factor. Okay. Now what we're going to do is we're going to use the scale factor to set up a proportion. All right. So that's big to small. So let's go big to small to solve for x. So big to small is 5 to 3. X, or that's going to be 10 to x. And I know that because E prime D prime corresponds to ED. Cross multiply, 5x equals 30. Divide by 5, we get x equals 6. All right, let's do the same thing for y. Big to small, 5 to 3. Y is my big side though, so that goes on top. And the corresponding side to Y, AB, is 12. Cross multiply. 3y equals 60. Divide by 3, y equals 20.